Hey everyone, and welcome. Today, we're going to pull back the curtain on one of the most critical performance tricks in the iOS world, cell recycling. It's the secret sauce, that invisible engine that powers that buttery smooth scrolling we all expect from our favorite apps. Oh, you know you have. We've all been there, right? You're just swiping through a list and then bam! It stutters, it jerks, maybe it even freezes for a second. It's super frustrating. And that little moment of lag, it's not just annoying. It's actually a huge clue that something really important is breaking down under the hood. So here's how we're going to break it down. First, we'll look at why that lag even happens. Then we'll dive into iOS's incredibly clever solution. It's recycling magic. We'll walk through the mechanics, expose the common and sometimes costly pitfalls that trip up even seasoned developers. And finally, I'll give you a checklist to get that perfect smoothness every single time. All right, so let's get into the core problem. Think about your social media feed or your photo library. You could have hundreds, maybe thousands of items in there. So how on earth do you show all of that without grinding your phone to a complete halt? Well, you've got two ways you could handle this. The first one, let's call it the naive approach, is basically just brute force. You create a brand new visual element for every single row. Got 1,000 photos? Well, you're making 1,000 photo views. You can just imagine how much memory and CPU power that chews up. The result is exactly what we're trying to avoid: lag and awful performance. But then you have the iOS approach, which is so much more elegant. Instead of making 1,000 views, it only creates just enough to fill the screen, and then it cleverly recycles them. And that brings us to the secret weapon itself, this whole idea of recycling. It's a really beautiful, efficient system that's all about doing way more with way less. Here's the best way to think about it. Imagine a super busy restaurant that used a brand new plate for every single customer and then just threw it in the trash. It would be incredibly wasteful, right? And slow. Of course, they don't do that. They have a small stack of plates that they wash and reuse over and over again. Well, iOS cells work exactly the same way. The cells are the plates, and your data, your photos, your text, that's the food being served on them. So where do these washed plates go? They're kept in a place called the reuse pool. It's basically a waiting room, a cache for cells that have just scrolled off the screen. They don't get destroyed. They're just hanging out, ready to be called back into service with fresh content. So what does that journey actually look like? How does a cell get from being on your screen into this reuse pool and then back onto the screen again with totally new information? Let's walk through it. It's really just a simple 5-step dance. So first, you scroll, and a cell disappears off the top of the screen. As soon as it's out of view, the system flags it as reusable and tosses it into that reuse pool we just talked about. Now, as a new row is about to slide into view at the bottom, the system goes to the pool and asks, hey, got a spare cell with this specific layout identifier? If one's there, it grabs it. And then your only job as the developer is that last step. You have to wipe it clean and fill it up with the new data for that brand new row. Simple as that. Now, this system is absolutely brilliant, but, and this is a big but, it is not foolproof. If you don't play by the rules, you can end up with some really bizarre bugs that are a nightmare to track down. So let's look at the most common ways this magic can go terribly wrong. The first, and by far the most common pitfall, is what I like to call the data ghost. It's when a recycled cell isn't properly cleaned before it's reused. You're scrolling down, and suddenly you see a user's profile picture, but it's next to the wrong name. Or maybe a checkbox for an item you never selected is already ticked. This is happening because the old state from a previous row is literally leaking into the new one. And for the user, it's not just a bug. It makes the app feel confusing and totally untrustworthy. So the absolute golden rule here is this. You have to explicitly reset everything about the cell every single time you configure it. You can't assume anything. If a label might have text, you set the text. If an image might be there, you set the image. If a button might be hidden, you decide if it's visible or hidden every single time. Okay, the next pitfall is where you accidentally sabotage the whole system. The entire point of recycling is performance, right? But if you do heavy stuff like complicated math or loading big files from a database, right inside that cell configuration method, you'll block up the main thread and cause, you guessed it, that choppy scrolling we're trying to fix. Another classic mistake is creating new little views inside the cell every time, instead of reusing those too. That's just like our restaurant buying brand new silverware for every customer instead of just washing what they have. So the guiding principle has to be this. Keep that configuration step as fast and lightweight as humanly possible. Do all your heavy lifting, like fetching data from the network, somewhere else entirely, long before that cell even needs to appear on screen. This one's dangerous. Remember how iOS asks the reuse pool for a cell with a specific reuse identifier? Think of that like asking the restaurant staff for a dinner plate. If you accidentally ask for a coffee mug, but then you try to put a giant steak on it, things are going to get real messy. Using the wrong identifier can give you some seriously weird visual bugs, or more often than not, it'll just crash your entire app. And that is the ultimate frustrating experience for a user. The only way to avoid this is with strict discipline and consistency. The identifier string you use when you register the cell, the actual class of the cell itself, and the identifier you use to ask for it later, those three things must be a perfect match. Always, no exceptions. And finally, we have the layout glitch. This is when you're scrolling and you see cells with wrong sizes or weird spacing, or things just don't look lined up right. This usually happens when layout rules, like constraints that were set for a cell of one size, aren't properly reset when that cell gets reused for an item of a different size. Honestly, it just makes the app look broken and unprofessional. Luckily, iOS gives us the perfect tool to fight this. There's a special method called prepareForReuse. This is the designated spot to put all your cleanup code for anything related to the cell's appearance, resetting colors, transparency, layout constraints, before it gets handed back to you to be filled with new data. Okay, so we've navigated all those potential traps. How do we put this all together to guarantee that smooth as silk scrolling experience we're all after? It really just comes down to this simple checklist. First, be exhaustive. Configure every single property on your cell every time. Don't leave anything to chance. Second, use prepareForReuse as your dedicated cleanup crew. Third, keep your configuration code lean, mean, and fast. Fourth, be absolutely meticulous with your reuse identifiers. And fifth, don't create new things when you can reuse them, even the little views inside the cell itself. In the end, this whole philosophy can be boiled down to one powerful idea. You have to treat every cell as if it has no memory of its past. It is a blank template. It's a clean plate, just waiting to be filled with new content at a moment's notice. If you can really get that mindset down, you've pretty much mastered the art of cell recycling. And cell recycling is just one of these many elegant, almost invisible systems that make our devices feel so incredibly fast and powerful. It really makes you wonder, right? What other hidden magic is happening just beneath the surface of the apps we use every single day? Thanks for joining me for this one.